This one is the one with all the Haribo, if you guys remember. This one is a Nintendo Switch, and it said this Nintendo Switch was bought brand new in 2019, and the touchscreen has never worked. I started a warranty return with Nintendo in 2020, but never got around to sending it. The Switch has never been opened or worked on. We'd be incredibly grateful if you could get it working. If anyone can do it, you can. I don't know if that's going to be the case, but I will try my hardest. Both my wife and I have been watching your videos for approximately 4 years and are big fans. Best of luck for the repair, Adam and Joe. It could be absolutely anything. Nintendo Switch bad touch screen. It could be something as simple as just replacing the digitizer. Not digitizer. I'm talking about the game card reader. That's what I'm talking about. So we do have 2 Joy-Cons that come with it as well. So I'm just going to put those up here. Do you think it's going to be something as simple as the game card reader, or do you think it's going to be something a bit more difficult? What do you think? But the reason I've got this one is because, again, I think it's going to be a relatively quick one to get done. A digitizer isn't necessarily a difficult issue. I could say that now and it could really, really come back to bite me. Yeah, it could just be a loose connection, but it's never been opened before. So in my head, the logic being that if it's a loose connection, somebody would have previously opened it and therefore would have had further issues. Now, what I'm going to do is just confirm a few things before we proceed with the repair. We don't have a game. We don't have an SD card even. So I'm going to go ahead and assume they don't have one, or they took it out before they sent it, which is probably something I would advise. I like this Nintendo Switch because we've got all the Pokemon stuff on the back. Let's just see if it's got any juice and that it powers on. It does. Now, quote unquote, there's no other issues with this device, so we should be all good. So the touchscreen doesn't work at all. That's so strange. It was bought from brand new. It's at 100% battery as well. Let's turn her off. So basically, the digitizer of the Nintendo Switch plugs into the game card reader, which then subsequently plugs in to the main motherboard. I don't know why they did it like that. To be honest, it doesn't really make too much sense, but because then you're just creating like another error in the connection chain. They're obviously a lot smarter than what I am, so there's definitely a reason for it. What a nice, easy fix this will be, and just nice to be able to get this back to the family. It is literally untouched. I'd hate to have to put this into another chassis because the digitizer on the actual Switch has gone bad. That would really suck because the chassis is, again, beautiful, great condition. All right, let's disconnect the battery now. It's definitely not loose. I wonder if it's developed a short. The issue being as well, we could well have 2 different cables that are potentially bad. Everything looks absolutely fine. Let's head on over to the scope and just I'm just going to give it a quick inspection. See if we've got any like shorted caps or anything like that that might be throwing us off, you know. So here we have the actual mini board that I was talking about that connects to the main motherboard, and I can't necessarily see, is there any bad pins here? No. All those pins look okay. What about the connections on the bit that connects to the main motherboard here? That also looks okay. Ribbon cable to me doesn't look snagged or anything. So we're looking for something that is just not working out of the factory, right? It could be this little chip here that is just faulty. Could be the case. What's that little bit of gunk or something there? It's on the same rail that the other one, so it should be okay. Let me get my multimeter on. Could have been dropped on the floor. I don't think so. No, I don't think so. Let's put this into continuity mode, which is the mode that beeps. Do you have any shorts? No. I'm just checking going into the chip. No. No shorts around that IC, which is probably where I'd suspect there to be an issue. What about on the back here? We're not going to have anything, are we? Okay, so I'm just going to put that game card reader over there for the time being and just check on the actual board itself. I'm hoping we don't have any issues here. I mean, that all looks really clean, hey? And this is where what I've just shown you is where it plugs into is here. And again, it just looks super clean on here. We could just have a dud resistor or something, you know. But again, that looks all right. What about the actual digitizer? How's the digitizer looking? We don't have any water damage or anything. I would highly doubt it considering how clean this thing is. No, look, all of those pins are absolutely fine. So I think first port of call is to put this back together and push all the connections just to make sure everything's connected. So I'm going to put one screw in there. I've plugged that in. I'm just going to plug digitizer in now. Let's see what happens now. No, look, nothing. Okay, we're going to turn it off because we don't have a fan connected. These things, they can last quite a while without having a fan on, to be honest. So what I'll do is I'll disconnect the battery again, and I'm just going to I will try a different game card reader to see what happens, because why not? Actually, I want to go with the same color board. I know that sounds really stupid, but yeah, I'm just going to go with the same color board. That one looks absolutely fine. That one looks a-okay, so we'll just replace it. Obviously, we want functionality instead of it being a nice same color. I know that there are some compatibility issues when it comes to the game card reader especially. Okay, that fills in there. Did we just have a dud game card reader? I'd find it hard to believe, but I mean, it could be, right? Let's plug her in and do another quick test now. Is it going to be the game card reader? Because if so, woof, no. So that to me tells me it's something on the board instead of being on the card reader. Now, just to rule out anything, I'm going to try one more card reader, just in case this one, for example, didn't work. And what I will do is go for a different color here, this one. We'll just see what happens. Could be the screen itself. Yeah, it could be. It could be the actual screen, which would be a bummer because it's in such good condition. And I don't necessarily know that I've got a screen that's going to be in as good a condition as what this one is. Another option is to go ahead and replace the screen itself, or we could replace the digitizer. But again, once you've taken it off, it's never the same. I'd rather put it into another housing to just ensure that we remain with the same quality. I mean, in shops and stuff, it's very common that you replace the screen and the digitizer. And as long as you have the glue for it, you can achieve really good results. I don't, however, have great glue for that type of job. I've got double-sided sticky tape and I wouldn't be comfortable just swapping it out with double-sided sticky tape. So I've put in a different digitizer now. No. And even if I'm giving it like a bit of a harder push there and it's not doing anything, I think it's going to be the digitizer itself, which is really weird, man. How does that get out the factory? Because again, it doesn't look like this is taking any hits at all. This is a super, super clean chassis, so I don't think it's taken any drops or anything. You know, it could have, but so what I need to do now is take majority of this out and plug it, well, pretty much all of it, and plug it into a new housing. Now, if I put this into another screen and say, for example, it doesn't work, I would then start looking at the actual components on the board. And I've never personally had it where changing out the game card reader or changing the chassis hasn't worked. So that'll be quite an interesting one to see what's going on. 3, 2, 1. Okay, so in a way, I'm actually really happy about that. Let me tell you why before you start judging me. I can put this back in the original chassis because the good condition chassis is absolutely fine. That's happy days. It's an issue with the board itself. Now, Adam, I know you're probably on the edge of your seat right now. Can I confirm that you're still here? Adam is the person that actually sent me this device for the free repair. Adam, I'm going to ask you this now. At this stage of a repair, if I was working in a repair shop, what I would do is contact the customer, aka in this situation yourself, and say, look, I'm now going to start doing some work to the motherboard. There is always a risk with any repair that things could go south. All right. I really hope that's not the case, because I'd like to think that I'm experienced enough that that won't happen. However, are you happy with me to proceed with that in mind? Is that at this stage, anything can happen. I will obviously try my hardest to ensure that that doesn't happen. But I'm just letting you know that things at any point can go south. Crack on, I trust you. Seems like it's going to be an interesting one, so please carry on and investigate more. Okay, my friend. Let's have a look on the actual board itself. Let's go onto the scope and take some measurements, because I'm sure this is about to get interesting. We are over on the board. Now, I don't know, guys. Is there a digitizer IC? I thought the digitizer IC was on here. I thought this was the digitizer IC. You know, like the power IC for digitizer. So I'm a little bit, maybe it's something to do with this circuit here. I know that's the LCD circuit, and I'm pretty sure that's the LCD driver. Unless, so if I turn it round, where's it all plug in? We've got this little chip here. I have no idea what that does. What's the first thing I'm going to do? I'm going to visually inspect as much as I can to see if I've got any issues wrong with this board. Now, one of these is the backlight driver, which, as we know, is not going to be the issue. But I don't know what this up here is. Let's hope. Let's just start measuring a couple of these resistors here. All of these pins look okay. Like, none of them look dodgy or look like they're hanging on for dear life. Let me just measure. Are we in fast? We're in fast, so I should be able to get good high feedback right here. 47. Now, I'm not going to check every single one to see what I get on other boards. I'm just looking for something that doesn't give me a resistance or that looks strange. So I'd go ahead and say oh, I thought we had one there. 23K is a little bit like, it's doable, you know. 47. So I've got 47, 47, 47, 23, 47. 47. 47. 33. 47. All of those resistors seem to be A-OK in my eyes. Wait a minute. What's that? What's that? 22 mega ohms on a resistor? Who are you fooling? Who are you fooling? Nobody, Mr. Resistor. Now, correct me if I'm wrong, guys, but having a resistor that size with that sort of resistance is crazy work. And look at that. That is accurate as well. It's not like I've got a dodgy reading. That is accurate. Let me check the one below that. 150. That seems right. This bad boy, though. You can't tell me that doesn't look suspicious. Oh, wait, now it's 2.8. 2.8 mega ohms. Right, let me get a donor board. No, mate, that's fine. Is it a resistor in the mega ohms? Oh, it's actually fine. It's actually okay. I've never seen that, I don't think. I thought that would have been a really nice fix. I got too happy. Let me just check this one as well. Yeah, I mean, it's normal, quote unquote. Wow. All right. Well, let's pretend like that never happened. All right, guys, please, for my sake. Did I check this one over here? I didn't, but 4K. 1,000 ohms. Fine. Oh. Is that cap from ground to ground? Absolutely not. I mean, if I've never seen in my life a cap from ground to ground. We got 1 ohm there. 1 ohm there. It looks ground to ground. No. No, don't tell me that. No. What? Why? If they've done that, I'm going to lose my head. This side is ground. True. The other side isn't. Right, okay. That must be the most useless thing I've ever heard. From what I know, caps are there to smooth voltage. So like what's this smoothing? This smoothing ground? We have a cap fuse. I've been caught out twice with this board now. The next cap I find, if it's a short, there's no way I'm gonna get excited. There's no other short with caps, unfortunately. Let me just see if there's anywhere on the screen that works. So I don't think it's necessarily a calibration issue, guys, to be honest. Can't be. And it reads games as well. It must do, right? Yeah, it works. I mean, that to me kind of just proves that all of the connections are okay. This could be an APU issue. Yeah, I don't want to factory reset though. 0.5. I'm kind of looking for anything dodgy, by the way. Is that ground potentially? I mean, what are the chances that both of those are ground? Very slim, in my opinion. Oh, okay, fine. 0.5. I mean, what are the chances that that one's ground? I mean, look. Pin 3 from the top, is that ground? I don't think so. Oh, it is. That's fine. 1, 2, 3, 4. Hold on. 5, 6. Okay, this one, I think this one's meant to be ground next to this one. So this is the board that we're working on. So let me go over to the donor and just double check. So the one that's next to this long pad, is that meant to be ground? No. Okay, so that's where we have our issue. So it's this pin here. So we get 0.4 on that pin. And on the board that we're working on, we get open line. So this is not connected. This is probably going to be CPU, but I don't know if anyone out there can confirm from certain documentation. I mean, I have it as well, but it might take me a while to load it up. Can anybody confirm? We're talking 1, 2, 3, 4 pins in, top row from the right, we have open line. Now, open line is usually meaning that something isn't connected. That's what that means. When something is open line, it means that it's not connected. And that would make perfect sense if it was something that was going to, say, for example, an APU, and you had like a cracked solder ball, you know? If it read as ground, where it's not meant to be, we have a short. But the fact that we get open line, as you can see from my multimeter just up here in the top right, that means that it's not connected. And on the donor, it is connected, and we get a 0.4 volt voltage drop reading in diode mode. That pin seems to go to a chip on the other side of the board. Is that chip the APU? Andy says goes to the APU. Wow. Let me find my documentation. Oh, wait. It goes to a little, what's that? Wait there. It goes somewhere on the board. It does go somewhere on the board. It goes to here first. Wait. I mean, look, it's giving me a little bit of hope. It's a component. It's a resistor. It's one of these. Okay, hold on. Yeah, okay, it all comes down to this. Let me just confirm. Yeah, it's the one on the right. I'm going to go into resistance mode right now, and I'm going to check the resistance of this resistor, okay? I'm going to do the one on the left, and then I'm going to check the one on the right. 1K. 1K. That would identify as normal. The other area that this goes to is the APU, unfortunately, and it's a really small pin. So, I mean, let's see actually what if I go into diode mode, right? I'm just going to check because it should be this top one here. Do I get open line? No, I get 0.4. What do I get here? 0.4. 0.4. 0.44. 0.44. 0.4. 0.4. So both of those resistors are reading the same. So one would assume that it's okay. But the question is, right, does it go from connector to one of these resistors to APU, or does it go the other way around? Does it go APU to a resistor to the connector to the resistor. Check the connection between the connector pin and resistor. I just want to make sure that it's definitely where it goes. And it goes to the top side, supposedly. So I should get 0.4. Wait, where does the one next to it go? Wait there. Because I want to see... Okay, so it goes to the pin completely opposite. So if I turn this around, let me show you, right? So the resistor next to that goes here on this one. Yeah, 0.4. And if I look up here, open line. Could I just solder a wire? Is that going to damage something though? Run a jumper, the board is internally cracked. I was thinking the same, because I would much rather run a jumper wire than reflow the APU. The success rate of me running a jumper wire is a lot higher than reflowing the APU. Apply pressure to the APU. I mean, I can do, but that doesn't really prove anything, because if it works, I'm still not going to reflow the APU. So that won't... I see what you guys are saying. Like, it most probably sounds like a cracked solder ball. The truth of the matter is, I'm getting some sort of voltage here. Should I not just do a wire from here to the place that we don't have? If it was APU, you won't have 0.4 in the pin. I see. That's a very good point. Do we agree that... I mean, yeah, that's a very good point. I wouldn't have 0.4 here, right? Because that's where it's getting generated from, is going to be the APU. I don't want to sound really condescending when I say this, but I feel like in this line of work, this is a great example of if I was to own my own repair shop or do repairs for clients, you have to know what you're good at and what you're bad at. If I bought a Nintendo Switch from eBay for 20, 30, 40 pounds, and I had a suspicion that it was going to be the APU, yeah, I'd go ahead and reflow the APU. If that didn't work, I'd probably take the APU off and reball it. This is somebody's device. This is somebody who has worked hard to be able to afford this device. This is where I stop and say, hold on, what are you happy for me to proceed with? What is our risk level here? I am not confident enough with an APU reball specifically to be able to go ahead and do this with this customer's device. The device in question works to a point they can play games, connect to internet, connect it up to a docking station. If I go ahead and mess around with the APU because I'm not confident to do so, I risk bricking the device. This is where I feel like a lot of people that do repairs could learn a good lesson. Again, I'm trying not to be condescending. I genuinely believe that people should try and take as much care as other people's device as possible in the repair business. Because at the end of the day, repairs is 80% customer, 20% knowledge. It's all about finding what the customer is happy with and what risk they are willing to take. I genuinely mean this. You could be the best tech. If you do not have customer service, I don't think it's going to work out. I think my consensus with this board is that we potentially have a crack or a line that's been destroyed throughout the board, and therefore we're not getting a connection between the digitizer pin specifically and this resistor. The best thing to do in this scenario is run the wire. The documentation that I have, it shows for this specific board, and it showed that there was a component there, and it should be the exact same as what the opposite pin was. You could be right in the sense that maybe the pin is loose, but I feel like I'm measuring from... Let me just see if I can get a better angle. Wait there. We've got a Tomlov 3D microscope. Let's use the 3D functionality here. So this is the side of where we have successful connections, okay? So if you look 4 in from the right, can you see 1, 2, 3, 4? That's where we get a successful reading. This is where we have our issue. Now, 1, 2, 3, 4 in. That looks fine to me. Put a little bit more pressure on, okay? 1, 2, 3, 4, right here. Oh, wait a minute. What's it going up? It's the connector. Look. Nothing on the pin. Joint, push. Okay. Hold on, guys. Hold on. Is there a way and a world where we win today? I am heating up the area. Why am I heating up the area? So it makes my life a little bit easier, and I don't have to use 10,000 liters of flux, because when we use 10,000 liters of flux on an LCD FPC connector, or just not LCD, but just an FPC connector in general, you can get that flux very easily underneath the connector, and it causes issues with the joints. So I'm just quickly blasting this with a bit of hot air to get some heat throughout the board so that we should be able to solder this nicely. And I'm going to use a tiny bit just on the edge. Just there. And now what I'm going to do is come in with a blob of solder and my soldering iron and just see if this works. Is that enough? Is that enough? Who knows? So what I'm looking for is I'm looking for a connection on the actual pin now. So do I get a connection here? No. Wait, is that meant to be ground? Is the one next to it meant to be ground? It just looks like a weird trace to go to ground, you know? Okay, it is meant to go to ground. Just looks a bit strange. No, even if I push this down, it doesn't. I don't want to push this too far in, because what you can do is you can also like destroy the plastic, right? And I don't want to destroy the plastic. Looks like you pushed it in a bit. Is the probe touching it? Yeah, probe should be touching it. Yeah, I mean, look, you can clearly see that we've got a decent amount of solder on there now. And the pin is soldered to the solder. Can you see? Try and say that 1,000 times. Yeah, it's definitely soldered. Check pad to pin. Good shout. Didn't test the bottom row diode readings. Maybe you have another OL pin. You're not wrong. You're not wrong. Yeah, it's definitely. I feel like that is definitely connected. So if that is connected, then again, if we put it into DC, if we put it into diode mode, we should have that connection. We should, and we don't. But the one above it, which goes to the same resistor but next to it, is 0.4. So it's like it is the board. It's like a crack in the board, or something. That's what I feel like's happening here. Maybe the trace was loose and the heat broke the connection. Very possible. Very possible. You didn't test the bottom. Should I test the bottom row diode readings real quick? We've got an open line there. Open line here. Open line here. So I've got 5 grounds on the bottom. Pin 8 on the bottom row. Is that meant to be open line? Where does that go? APU. Also goes to N2 on the back, which is a diode. Oh no, wait, that's a cap. Here. This cap. Okay, so do I get a reading there? I get a reading here. Look, 4.1. 4.2. Do I get a reading here? But I don't get a reading here. Here? Here. So that's also meant to have a diode reading. So I've now got 2 locations. Wait, where's that third one? Let me see if I can find where that third one is. Sorry, see if it's not meant to be open line. Where was it? Was it here? No, here. No, here. No, here. Wait, I'm sure there was 2 that was open line on the bottom. Right there. Here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Where do you go? APU. N80. Where's that? Help me get my head in the right place. So I've got a Nintendo Switch that the digitizer doesn't work. I have the readings on the board in other locations, but I don't have the readings on the connector itself. Am I right in thinking that the APU in this scenario is actually okay? Or, I mean, because those caps and resistors, they're not going to generate the power, right? The power is going to come from the APU. So I'm going to go ahead and assume that everything APU related is actually okay, but it doesn't mean the connector because I'm also pushing down on the pads. There is internal layer damage here, like a cracked board. That's what I'm thinking. I think the connector's okay. The general consensus is that we're going to wire 3 separate wires from points where we seem to have these voltages to the connector itself. Now, there is a heavy chance that the connector could be damaged underneath those pins, but I feel like when I'm probing with my multimeter, I'm getting on the pads, which would then suggest that there's internal layer damage, like a break in the connection, that's stopping all of those good connections from getting to the connector itself. I've checked the soldering on the connector to the board, and that seems to be a-okay, and I've done a continuity test to confirm that I get a measurement between the board itself and the pins on the connector. So I think we just go for the wiring of each separate location for the 3 that I'm getting a no connect onto the connector. Do you know what I would say? I would say it's very rare for only 3 connections to be broken on a board if we have internal layer damage. If you've got internal board layer damage, you would expect a lot more things to go wrong. And maybe there are a lot more things wrong with this device that I'm just not seeing, and because they're not obvious to people who are playing the device. I've got 3 different points on this board that I need to solder wires to, and it's going to be rather difficult. The reason why it's going to be rather difficult, we've got this cap here, which is obstructing. That's the word. I was going to say obscuring. That's definitely not the word. Obscuring this... No, obstructing. Sorry, I've done it again. Obstructing this pin here. And then we've also got this pin here, which I need to solder a wire to. And this one here. Now, good news is with the top one, I've already put a little bit of leaded solder. And that's what I'm going to have to do on all of them, just to try and get the best connection that I can possible. It's right next to plastic. I can't get too close to the plastic, because otherwise that connector is going to have to come off, and I'm going to have to start the whole process again. Now, I think that might be a little bit too big. Yeah, that's much better, hey? We need to make sure that we're tinning the wire, because I want to just ensure that we get the best connection that we possibly can. Okay, so we've got a little bit of wire here, okay? And I've got my soldering iron, which is currently set to 430. I don't need it set at 430, mind you. I'm just going to take off the enameled, just like that. And now what I'm going to do is run it to the specific places that I need it to go to. So again, what I'll do now is I'll come in with a little bit of flux. The key thing here is to work to your advantage when it comes to angles and whatnot. So you want to rotate the board where you need to rotate the board to make your life a bit easier. So for example, if I was to solder this way, it is a little bit more difficult to do that. And then I'm going to turn it around. So here we have our first wire going on, which in turn I'm going to add a tiny little bit more flux here. We'll just at least push this flux up to the cap, and just hopefully, I'm going to say simply, but that will be fine. To make sure I'm not pulling any wires, because if I start pulling these wires now, we risk like components going places where we don't want them to go. So I'm just going to quickly tap this flux here, just to help my cause a little bit. And I'm going to have to cut this wire now rather than pull everything off. way too much, so I'm just going to get some of that off. Like, I don't want that much flux around connectors. There's just no need. Now it's enameled wire, so it's not going to short out against anything. So I just need to kind of maneuver this as best as I can. Now, you might be thinking, oh, but Joey, it's resting against that cap. So this cap doesn't necessarily matter if it's touching the wire. And the reason being is because this is enameled wire. So there's no connection that's touching these two ends here. That makes sense? And now if I try and, oh no, I've tried to wiggle that and it's come straight off. So I need to come back in here with maybe just a little bit more flux. Or I tell you what I might do. I might keep the wires there for the time being, reroute the other ones, and then solder them all at the end. If that makes sense, I might try that instead. I think that makes more sense because then I can kind of work out which wire needs to go where and what I need to solder first, and etc. etc. So that's one of them. There we go. Right, that stuff needs to come off my iron straight away. Did you see how I stopped like pretty much straight away there? It's because that is how you end up scratching the board and stuff. I don't know where that's come from. But as soon as you see anything like that on your board, clean your iron. ASAP. I'm still not necessarily happy with how that looks. So what I'm going to do here is just add a little bit of flux to the joint and come in with some more solder. I'm looking for a big amount there. I need a big amount of solder on that. Looks a bit better. And now if I take my brush, if this wire comes off, it wasn't fit for purpose. That's the rule. Okay, so that's that. I'll cut again just for now. And then I'll do all the solder connections in a minute. Put solder mask on if this rips. I need a place to find the signals under the APU. Okay, fine. Yeah, I'll do that in a second then. I can do that now. Let me put the thingy on now before I start moving the board around. Hard as a rock. Whoa, what happened there? Like a flux explosion. Perfect. Okay, same thing, same deal. And a dabbity doodah. The Joey rub, as PLD calls it. It's got its own name. Is that on enough? I think so. I'm pretty sure. Which means that we come in with our dippity doodah dippity day. Let me just make sure that that's not. Yeah, it's not going anywhere. Stop. I'm going to put that there. I know this isn't the best way to route. I know it doesn't look pretty, guys. It doesn't need to look pretty. It just needs to be functional. Okay, my main worry and priority here is just getting it working. And hopefully they should never, the people who sent me this should never have to open this Nintendo Switch again. That is the goal. Okay, so I've got all the wires kind of routed where I want them to be routed to. So now is the really difficult part. Trying to solder without burning the connector with a soldering iron that is set all the time at 450 degrees Celsius. Now I'm going to measure this and make sure I get the reading that I need. I need to see 0.4 on that pin. Good. Now, a couple more. So we've got 0.4 there. I think I might tack that down now. And then once I get this soldered on, I can put it down proper, pretty sure. Yeah, this is pin number 5, which is going to be the difficult one, to be honest. I can't move the cap. I can't with hot air. I mean, I have to come in from the back, and I think that's going to affect the wire. I can't come in from the back. How am I going to do this? Okay. I might have to try and solder it directly to the pin. I literally need to solder it like this without it bridging. Oh no, this is horrendous. Hold on. No. Okay. All right. Okay, hold on. Multimeter, let me just double check and make sure I get a reading that I need. So on our donor board for this exact connection, we get a reading of 4.9. Okay, so that's what I need. I need 4.9. Do I get 4.9? Or do I get something else? 4.9. Okay, right. Wait, was that 8 or have I sold it to the wrong one? No, that's cool. Okay, good. Right, so this does go to 8. That's all it needed, man. And you have to be so careful because one little slip there and you desolder the whole thing or run another wire off the board or something like that. But you just need that one little chance. And when you see it, it's so relieving, man. Just that little bit of solder blob. There's obviously one major part here that I need to do, and that's going to be to give it a nice clean and get all that gunky flux off. But I'm just going to put that down there. So what I'm meant to get on pin 8. 040 is what I'm meant to get. Do I get 040 here? 040, well, 041, but I mean, hold on. 043. Goes 4.2 and then drops down. I'm gonna say within tolerance. So this is what we get. Okay, Ben says, by the way, he's just compared every single reading that I've read out, and they're all fine. All I'm going to do now is quickly give this board a tiny little bit of heat, maybe like 150 degrees Celsius, and dab away at some of the flux that I've got around the connector, because I don't want that flux there. And then I can put the connector on, and hopefully we've got touch. If we've got touch, we seal this up, and we never touch it again. This is how we look after a quick clean. And again, I'm being super careful here, but that looks pretty clean to me, guys. What do you think? So we have some of the flux. Oh no, I don't like that. There was flux, exactly, yeah. There was flux there. So that's my stupidity, really. That's my stupidity. There was flux there. Okay, here we go. I haven't been this nervous for a repair in a very long time. Adam and Joe, if you're watching, I wish this Switch the best of luck, and I hope nothing goes wrong. I really do. What's the point of having a Nintendo Switch if you can't play touchscreen? Does it power on? Guys, I'll be honest. If this powers on, it's a massive win, okay? If this powers on, it's a massive win. 3, 2, 1. It doesn't power on. Yeah, the backlight's not on either. Let me try one more time in case I missed the button completely. All of that for nothing then? The reason I know the battery's not dead is because this had 100% charge. The backlight's not coming on at all. See down here? Wait. Okay. Wait. Oh! My guess here is that when I've put this on, it's maybe broken a solder connection. One of the wires that I've done. That's that, or it's shorted against something. That's what I'm thinking. That's what instantly comes to mind. So I think what I do now is I take this off and I have a look under the microscope to see what's happened. And I can do that whilst it's in the chassis. Here's the connector. Everything looks the same. That seems on. That seems on. Okay, let me try and disconnect the game card reader. So the issue isn't necessarily the game card reader. The issue is something else. I'm going to take it back out the board. And I'm going to disconnect the wires from the respective places that I've soldered to, not the connector. I'm not going to disconnect from the connector. I'm going to disconnect from the places that I've soldered to, because there isn't anywhere that this should really be shorting. Like even these resistors here, it shouldn't theoretically be an issue, right? Because it is enamel coating. Let me try it just like that, because that's not pushing the wire, is it? No. I was just checking to see if when I push down, it like destroys all the wires, but I don't think it does. It's not touching that pin. That's another thing I wanted to confirm as well. Has to be maybe something on the other side of the board. Shorten out. It's the only thing I can think of. Is this chassis conductive though? I don't think it is, because I think it's plastic, right? Let me start taking some things out and seeing one by one, because then maybe I can even track down what it is. So I've disconnected the digitizer completely now. I have to be super careful, man, because all of these wires. I'm going to turn onto the back and just check some of these connections. We've got this one, which kind of skirts all over the place. So this one goes to the back, which we've confirmed is A-OK. Well, when I say confirmed A-OK, so it turns over to the back. It goes here, there, steers clears of those, goes onto the metal shielding, which again, I don't think any of that is scraped enough to be ground. And we get the readings, right? We get the readings on the connector. So, you know, it can't be a short in that regards. Do we think desolder one by one? Disconnect one at a time component and see what, yeah, that's what I think, Rich. Yeah. I'll start with the one that I haven't glued. Okay, wire number 1. Will you our issue? 3, 2, 1. You were. Well, I got very lucky that it was the first wire. I got very lucky it was the first wire, because the other ones was glued. All right, turn it off. That's good news. Should I plug in the digitizer now and just see if it works? Let's see what happens. Card reader plugged in. Do I get touch? If I do, it's a miracle, by the way. Absolute miracle. Does it power on? It does. Watch me get like only half of the screen touch or something. Nothing. Okay, I'm just going to test something. Now that I've disconnected the game card reader, does it turn on like normal? No, it doesn't. Now I've disconnected the digitizer cable. I'm just trying out some stuff, and now nothing. Doesn't look any different, which is a good thing. Where's the end of the wire right now? On the back of the IC. So it's on. I technically put it on the back of an IC, just under here. So when I put it down, it was pressed against it. Let me, I think, unscrew and take a little bit of pressure off. So now it's not squeezing everything down. Wait there. That's it. That's a longer boot, or not? Okay. It seemed like a longer Nintendo boot. I reckon disconnect the other wires is now my next option, I think. I'll re-inspect to see if there's anywhere that like could be shorted. Yeah, so look, that wire, can you see? Can you see the wire on the IC? So it's like on the IC. So when it pushed down, it's not going to be shorting out with anything. Shouldn't be anyway. I'm going to disconnect both of them again and see what happens. Could have shorted this chassis to ground. That's a good point. That's a good point. Before I do that, yeah. But is this ground though? Is the chassis ground? I thought it was plastic. GG. All right. The more you know. Absolutely right. Absolutely right. Let me get a bit of tape then. Cool. Right, here we go. Is it going to turn on? Was that wire shorting out to the chassis on the back? I mean, I didn't know it was ground. No, I thought that was it. I'm gonna have to desolder. It did just boot. So why would it? What was the only thing that I changed when I booted it? So the only thing that changed was that I plugged in this, right? And I checked around the connector since, and I've not got anything that looks bridged or anything like that. Does IPA work on this? We're about to find out. Looks like it does, by the way. Very slowly. Take that back. Heat. Yeah, seems to be like the only thing. Okay, just to confirm, that wire is here. Can you see? That wire's here under the tape. And then I'm just going to disconnect the other one because why not at this point? Just see if we get a normal boot. Okay, all wires technically disconnected. So if we don't get a boot now, it's GG. It's imperative. It's imperative that we get a boot on this one. Imperative. Just boot. Come on. Wires removed. That's better. That's better. That's better. Okay, right. So thank goodness we have a boot. It's just, I think that diagram can't be right. I don't think the diagram could be right because everything was lining up and we know we had a continuous path, right? Because the readings that were on the components were the same as what was on the connector. I mean, I'm going to try it. I'm going to try it because I've seen stranger things. There is a 99% chance this doesn't work, FYI. I'm talking 99. 99.9% this doesn't work. Okay, hold on. What this proves to me, I think the whole time, is that the connector, when I pushed on it, is what is shorting out the switch. So if I now push that back and plug it in and we get a boot, I don't know what. I don't know. I don't know. And now we don't get a boot. Honestly, I don't believe it. And there's no wires connected now. Let me take out the cable, the digitizer cable. Every single time I plug in this game card reader, it doesn't boot. Okay, so everything's been taken out and put back in. Does it boot? No. Right, let me remove some of these. That's where that pad is gone. And then let me just check that resistor is still where it are, which it is. I know this stuff isn't, I want to say this stuff isn't conductive. I don't think there's a cut there in the line because I can still see the copper. I think we're okay. Now I've not screwed it down. Maybe I'll give it one screw just in the top. Please turn on. If it doesn't turn on, it's going to be a nightmare if it doesn't turn on. Oh. Okay. We've been here before so many times. We've been here before so many times. I'm going to turn it off and I'm going to turn it back on without this connected. Okay. Let's turn it off. Now that we don't have all of those wires and everything, should I put a new connector or should I keep the same one? Because I don't have all the wires and stuff connected now. Do you see what I'm saying? New? The touchscreen won't work because we don't have those connections. I don't think it matters. And let's just see if it boots. That's in there nice and good. Now, if this doesn't turn on now, it's got to be digitizer. It has to be digitizer. Or is it the connector? This whole time, imagine, would be my luck, you know. Theoretically, I can take this connector off and the machine will boot. So the game card reader we know is good. Like nothing was happening with that. So let me put this one back because that's not the customers. This one is the customers up here that I've got. Now, there's quite a lot of caps here. Quite a lot of caps. So we do need to be cautious. And I'm talking about when I'm pulling. So when I'm pulling this off the board, I need to be careful. The heating element is not a massive issue. The issue is the components around it. Where are my small tweezers again, man? Why do I keep losing these tweezers? Yeah, I'm also being careful of the chip on the back. Yeah. I'm going to have to try and slide it off, I reckon. Extracted. Now, for interest's sakes, should I measure those pads now? Connector itself looks fine. Again, one of those things that I really do highly doubt, but worth doing it whilst I'm here. So I'm in diode mode. So for example, it was this one. Yeah, look, nothing. And it was here. Wait, 1, 2, 3, 4. No, it wasn't. It was here. 5. Yeah, nothing. And it was 8. Yeah, nothing. Look, I still get nothing. I still get nothing on the pins. So I guess now it's like, let's just put it back together and hopefully it works. Can you see a stress bend in the board up there? No, I don't think so. The area we're looking at specifically is going to be here. It doesn't look bent at all, does it really? That's where I put the glue, by the way. But it doesn't look bent at all. You know? I mean, look, it came out of the factory broken. So, like, clearly it passed most of the tests. Just not the, like, important. The important one. What gets me is, like, how on earth, like, the game's worked? Because if the game card slot reader didn't work, I guarantee they would have sent it back under the warranty, because what's the point at that point, right? They didn't even never test really playing with the digitizer. But if the game card slot didn't work, it would have been one of the first things. Like, put a game in, oh, it doesn't work. Let's get that sorted, because that's a huge issue. But when it comes to digitizer, I completely understand that they wouldn't have really necessarily needed it straight away. And then it's like, well, we then have to be without the Nintendo Switch. Send it back to Nintendo. Do X, Y, Z. What's the point? I completely understand where they're coming from as to why they didn't return it under warranty. 3, 2, 1. Does it turn on? Okay, it does. Now, here's my issue. I can put another connector on, easy. But now, is that going to cause further issues down the line? Because now they can't even play their handheld games. So another connector needs to go on, really. But I'm just scared that if I put another one on and then it does some weird shorting out thing again. It's definitely, I don't know if you guys agree, I genuinely think that it's definitely something like a crack in the board, which is what's causing that every single time I put that connector on. I don't know if it's like causing some sort of stress or fracture on the board itself, which then reignites the issues. It's just now it's a bit more sensitive because it's been exposed to heat and stuff, which is why now it's not coming on when that happens, because it's getting maybe that little bit deeper. Do you see what I'm saying? Because it's had work done to it now. I'm going to have to put a connector back on because I can't not do that. Can you see if you trigger the short by pressing a bit on the board? Yeah, I guess at this point there is literally no reason why I can't do that, just to test my theory, right? Let me put some pressure on the board. So I'm going to put some pressure here, okay? I'm just going to put my finger, all right? I think we've confirmed. Right, okay. Yeah, it's cracked on the inside. Is it ever so slightly out of line? Do you guys think it's ever so slightly out of line? No, I mean, I can't see. It's kinked. I don't think it is. I think I've seen boards with so many bends and stuff that work. I mean, yeah, there's a chance that maybe the bend in this is so like just in the right place, but it is slight that it could be messing something up, but I don't know, man. And unfortunately, there we have it. That is the end and conclusion of this video, is I wasn't able to fix it. But I mean, what an issue to try and fault find. I really enjoyed the process of trying to fix and learning about the different connections and potentially, you know, the APU being an issue. But I think general consensus, as I've confirmed before, was probably some sort of crack in the board. Now, I'll stick to obviously all the facts and everything. Just know that the people who sent this in have been sorted. Don't worry about them. They're all good. But I was saying in the live stream, that is the first time for me personally that I've ever had a repair for a customer that's gotten worse, you know, and I've done hundreds of jobs working at a repair shop previously, and I've worked on hundreds of devices personally from my own home. But that's the risk that you run when you get into this game. It does happen to everybody. Most people, I'd say. Not the outcome or conclusion that I wanted with this video, but nonetheless, I hope you enjoyed it. Thank you very much for watching. If you did, hit the thumbs up button, subscribe to the YouTube channel if you are new here, and as always, I'll see you in the next one. Peace.